Hello students, today we are going to start one more new topic side by side, that is differential equation. Okay, so what do you mean by differential equation? That are equation which involves differential coefficients. Differential coefficients, or in short we call them as differential as well as. For example, let us say dy by dx, okay, or d square y upon dx square, and so on. Okay, so differential equation is classified under two parts. In some of the semester you will read it ordinary differential equation in other semester, and partial differential equation in other semester. So what's the basic difference between those? Let me classify this as ordinary differential equation. I would be writing d in short for differential equation, and second is partial differential equation. So what's the basic difference between ordinary differential equation and partial differential equation? Here all the differential coefficient, are reference to or have reference to single independent variable. Okay, so there will be a single independent variable, whereas we already covered in the last lecture that partial differential equation where there are two or more independent variables. So there are two or more independent variables and partial differential coefficients with respect to any one of them. So let me give you some examples to make it more clear for you. Let us say here the example is e to the power x dx plus e to the power y dy is 0. So can we say, if we want to rephrase this example, can we say e to the power x dx is equal to minus of e to the power y dy, and can we say dy upon dx is nothing but e to the power x by minus of e to the power y, or can we say minus of e to the power x minus y? So can we say here there is dependency over only x variable, y variable. Okay, but here you will see that in the case of here y is dependent on x, but in the case of partial differential equation, let us say we have example of del u upon del x plus y into del u upon del y is equal to 2u. So can we say u is dependent on two variables, that is x and y? So can we say two or more? If you want to cite example of three variables, we can also write the same del u by del x plus y into del u by del y plus z into del u upon del z is equals to 3u. Let us say any example. So here u is dependent on x, y and z, but here y was dependent on x only. Okay, that's the reason it is having the derivation of here it is d means complete derivative and del means that is partial derivative. Okay, so this is the basic crux of ordinary and partial differential equation. So let's move to the next topic, which is more relevant for objective point of examinations, that is order and degree of differential equation. So let me write it what is order for you, so that you can revise the concepts later on. Order of the highest order derivative occurring in the differential equation, in the given differential equation. Okay, and if we talk about the degree, then degree is nothing but the degree of the, or basically power of the highest derivative. That highest derivative you have got, highest derivative occurring in differential equation, but the clause is there after the equation, has been expressed in radical free form. So there should be no radicals free form, means that there should be no no fraction part should be at the power. Okay, let me quote you some examples for you. So let us say example number 1. Example number 1 is y dy by dx plus is equal to x dy by dx whole square plus c. Okay, so if we talk about the, can we say what is order of the highest derivative? So what is the highest derivative is existing? That is dy by dx, and what is its power? It's 2. Okay, so first we'll have to scan the whole equation and check whether there is dy by dx or d square y by dx square or dqy upon dx square. You have to scan it one by one. The highest order would be considered. Okay, so here the highest order is dy by dx and the power of that is 2. Okay, so can we say the answer is first order and second degree? Okay, now let's talk about one more example. We'll do 5 to 6 examples under this to get it more clarity over this, because many of the students used to make mistake in such basic questions. D square x upon dt square plus 2x cube is equal to 0. Okay, again see here it's second derivative, so and power of this is 1. So can we say answer is second order and degree is equals to 1. Let me quote one more example for you. Example 3. Can we say 3 d square y upon dt square plus 4 into dy upon dt cube plus y square plus 2 is equals to x. So here y is the dependent variable. Okay, can we say here that what's the highest order derivative? Here you will see dy by dt. So first step is that you always check for the highest order derivative. There are dy by dt and d square y upon dt. So who is the highest order? This is the highest order, and for the highest order we have to check the power. So its power is 1. Remember this thing, we won't be considering this part because the power order of this is higher. Okay, so can we say order here is 2, and what's the power of this term? This is 1. Can we say degree is 1? Okay, let me quote one more example for you. Example 4, that is d square y by dt square plus dy by dt cube plus y to the power 4 is equals to e to the power minus t. Again see here first order, here second order, then definitely second order will be considered, and the power of this is 1. So again can we say order is 2, degree is 1. Okay, now let's focus on bit tricky examples. Okay, 1 plus dy by dx ka power cube, and this is 3 by 2 is equal to k d square by d and dx square. Now here most of the student used to make mistakes, because directly they will look at the result that this is single power, this is double power, double order, this is second order, and this is first order. So what they will do, they will consider this, and power of this is 1, so they will write the example as order 2 degree 1. But remember, your answer will be wrong, because in our theory we have mentioned that after the equation has been expressed in radical free form, and this is having a radical term at the top, so let's make them radical free. How will do it? Can we say, if we take the square on both side, can we say 1 plus dy by dx ka whole cube, and this is 3 by 2, and squaring will be like k d square y by dx square ka whole square. So this will be cancelled out, and can we say 1 plus dy by dx to the power 3 to the power 3 k d square y by dx square ka power 2. See, now is there any fraction part or at the exponent? No, it's a radical free form, and we'll look who is the highest order. This is the highest order, and the power of this is 2. So can we say our answer as order is 2 and degree is also 2. Okay, let's consider one more example. Example 6. This is dqy by dx cube plus 4 into under root of dy by dx ka 4 plus y square. Remember this thing, that this is not fourth root, this is 4 outside, fourth is constant. Okay, so can we write this thing as again dqy by dx cube is equals to minus 4, and this is dy by dx ka power cube plus y square. So again it's a radical form. So how do we solve this radical form? Can we take the square both side, dqy by dx square, and this is 16, and can we say dy by dx cube plus y square. Okay, now you can easily compare. This is a radical free form, and which is the highest order? Dy by dx is single order, dq by this is third order, so odd, and what's the power of this? This is 2. So can we say order 3 and degree 2. Okay, so this is all about the order and degree of the differential equation. Okay, now let me do one more basic topic for you, because we will be building whole of the crux of the linear and non-linear differential equation. So we must be aware about what's the difference between linear and non-linear differential equation. Non-linear differential equation, how will you differentiate that? How is this a linear equation or is this the non-linear equation? So let me write you some conditions for you. A linear differential equation exists if it satisfies the condition, that is the dependent variable, let us say we are writing dependent variable as y, and its derivative appear only to its first power. Okay, remember this thing, appear only to first power. I'm highlighting the important things, that is there should be y dash. If y dash is existing, y double dash is existing, y triple dash is existing, or y dash, they all have power equal to 1. There is no power 2, otherwise that will be case of non-linear differential. Second differential in that they are not multiplied together, means y should not be multiplied with y dash. Both are the dependent variable. Okay, so dependent variables are not multiplied together. Okay, let's talk about the third condition, that coefficients can depend on the independent variable. Okay, so coefficients can be there, and sometimes coefficients can be x and y, but you have to check that whether the coefficients are dependent or independent variable. So those can depend on independent variable, let us say x, but not on y, because y is a dependent variable. Okay, so what's the nonlinear differential equation? Nonlinear differential equation, then nonlinear differential equation is that y or its derivative are raised to power 1, are raised to power other than 1. Okay, other than 1. Let us say we have y, then if y dy by dx whole square is there, then we'll say this is nonlinear. Second, or are multiplied together, or are multiplied together. Okay, the dependent variables and its derivative is multiplied together. And third condition is that or appear inside a non-linear function. Let us say the dependent variable y is like this type, sine y or log y or e to the power, then we also will consider this as non-linear differential equation. Let me cite some examples for you just to get it more clarity. So example number 1, here dy by dx plus y. Can you think of the rules which we have discussed? And first think, because I will write down the solution definitely, but think it on your own. So can we write this as y dash plus y is equals to 0. So see here, its power is also 1, its power is also 1. Okay, so this is the case of linear differential equation. Okay, second case, example 2, x square d square y by dx square plus x into dy by dx plus y is equal to sine x. Okay, let me check. First rule is that the y dash or y double dash, they will all have the power 1. So can we say its power is 1, its power is 1 also, so it's satisfying the rule number 1. Okay, can we say, let me write it as here, that is y and y dash, sorry, y and y dash and y double dash all have power 1. Okay, second condition is that, see, there are some coefficients also, but remember these coefficients are independent. If in place of x square, if there would been term like y square, then definitely this would have been case of nonlinear, because we have that they are not multiplied together. Okay, here if dependent and differential coefficients are multiplied together, then that would be the case of nonlinear. But here can we say coefficients x square or x depends only on x. Okay, so here can we say this is the case of linear. Okay, let me do one more example for example 3. Can we say dy by dx minus x square plus 1 into y is equal to e to the power x. Okay, so can we say here, that is here y dash and y has only first power. Okay, so this is also the case of linear. Again, let me consider one more example. Example number 4, can we say dy by dx plus y square is equal to 0. Now think of this, see here y is there and the power of y is 2. Okay, so can we say this is non-linear, because y square has power 2. Okay, let me write one more example for you. Example 5, that is d square y by dx square plus y into dy by dx is equals to 0. Is this linear or non-linear? It's non-linear. Why? Because y is a dependent variable and this term is also dependent variable. So this is rule 2, that is product y into y dash exist. Okay, hence it's the case of non-linear. Let me consider example number 6 for you. Can we say dy by dx plus sine y is equal to x? See, we also mentioned over here that if dependent variable appear inside some functions like sine, log and exponential, then also will change the things. Okay, or that would be the case of, can we say, sine y is there and hence these cases of non-linear. Okay, now let's consider the last example, that is dy by dx whole square plus y is equal to 0. This is very simple. Can you see here, this is y dash ka whole square, so power is having 2 y dash whole square, hence this is non-linear. Okay, so this is basic about the differential equation. In the next lecture we will be focusing more on the topics of differential equation.